Okay, guys, I'm Aluko Enoch. Welcome to the part 2 of our math tutorial on differentiation and integration, additional mathematics 0606. Okay, so this is part 2 section. Okay, you may need to go ahead and check the part 1 of this video so that you gain better understanding of how to complete this type of question. Okay, so let's take a look at the question 8 now. The graph of y equals to x squared minus 6x plus 10 cut the y-axis at A. Whoa. Okay, so the graph of y equals to x squared minus 6x plus 10 and y equals to x plus 10 cut one another at A and B. So the line BC is perpendicular to the x-axis. Calculate the area of the shaded region enclosed by the curve and the line AB. Showing all your workings, guys. Showing all your workings. That is not funny, guys. I think I will need to manage my board now, guys. Let me just demarcate this now. I may need not to use yeah, let's go ahead with our rectangular boxes. Okay, let's see what will happen. Let me quickly make a note here. Now the first information here now, because if you look at this curve now, this quadratic, or what do you call it, trinomial equation is also quadratic. Okay, this parabola, this curve cuts. So let me just put this in here, this point A here. You can see that the curve and the line intercept at this point. So at this point A now, we can equate you can do equation of the line. The equation of the line, this one is equals to the equation of the curve. So we can just do y equals to y here. So by implication, to find the coordinate of A here, just go ahead and do the parabola, that is x squared minus 6x. Guys, that is 6x. Okay. Minus 6x plus 10. I think I just need to write that very well. Sometimes I can be quite funny. Okay, equals to the equation of the line, that is x plus 10. So that is at point A. Then to get the coordinate of A, okay, don't forget that this is a boundary point. So it's going to be, A will be something like 0 comma y. Do you understand? Because x is 0 on this, 0 comma y. Okay, so when y are equal, okay, so we have this here now. So I'm sorry about that. Okay. So I have just bring this one here. I have we want to have two possible value of x. Sorry about that, not 0 comma. So two possible value of x that will satisfy this equation though. So let's just go ahead and solve. So I have x squared. Now this is 10 and this is 10, so this will go out. So bring this one here. So minus 6x minus x will give you minus 7x equals to 0. So you can factor out now. So I have x into x minus 7 equals to 0. So what are the two possible value of x? So x equals to 0. I confirmed that one before now. Or x equals to 7. So this is the second equation that satisfies x equals to 7. Okay, guys. If they ask us to do anything, that I will go ahead and substitute, but I'm not sure I need to do this. Okay. So for now, I will just keep that now. So the point A now. So we have the coordinates for A now. Okay, so that's when y are equal. So we have this the following value. So that is at 0 comma y, we have that. So at A into 0 comma y. Let me just put this for 0 comma y. So this is when y equals to 0, so we have 7 comma 0. And also we can also conclude there also, because if you look at what we have there also, we can see that let me just go ahead and show you something very interesting. Look at this point C now. Do you see that the value of the x value for b coordinates here. Let's call it x b coordinates, okay, comma y. And this one, let's call it xc coordinates. This is c, okay. So xc coordinates, comma y. So you can see that xc, the coordinate of xb is the coordinate of x for b is the same coordinate for x for c. So I can put that xb coordinate is the same thing as xc coordinate and is equals to 7. Okay, guys. So we have that a is 0 comma y. So that's pretty cool. So now, guys, I don't think we have any problem again, because you can now see that x, the range of the value of x, or can I say the interval? Okay, so you can take the coordinate for x from 0, this a, to 7. Okay, so that's it. So now, guys, calculate the area of the shaded region. Now if you look at the area of the enclosed region now, guys, to complete this one, you just go ahead and see. Now you see that the line is above the curve, so that will be equation of the line minus the equation of the curve. If it were to be something like curve like this, and you have a line, and you want to find the equation of this shaded region, then you are going to do curve is above the line, then you do equation of curve minus line. But for this one, you do equation of line minus curve. So integrate equation of line, and that is x plus 10, okay, that is yb. Don't let me call it yb. So this is the equation of the line, though, it's clear. X plus 10, okay, minus from 0 to 7 again, equation of the this one, curve, and that is x squared minus 6x plus 10. And we know the limit for the value of x already from 0 to 7. So go ahead and integrate this. So if you integrate this one, you are going to get x raised power 2. Yeah. Hope you know how to integrate, guys. I will not waste my time with this. Trust me. Okay. Plus 10x. You know how to integrate already. Before you can do application, you should know how to integrate it, guys. Don't tell me that. What is Aluko doing again? Okay, I'm sorry about that. So then you take the from 0 to 7, the limit from 0 to 7, then minus, go ahead and integrate this one. You have x raised power 3 over 3. And the best thing for me is just to put this one in bracket so that I don't make mistake, because this minus will affect everything inside the bracket. So minus 6 s squared over 2, then plus 10x. For some reason, I think I'm cool with the way I managed the board this time around. Then I'm going to take the limit from 0 to 7 also. Okay, so let's complete this now, guys. I'm going to plug this in calculator now. Okay, so definitely when it is 0, it will be 0. Okay, when it is 0, it will be 0. So I just need to go for 7. So that is 7 squared is 49 over 2 plus 10 times 7. So let me just do that. Do this one. 7 squared over 2 plus 70. Yeah, I think I'm cool. Plus 70. So that is 189 over 2. So 189 over 2 minus, when it is 0, 0. So it will still be 189 over 2. Right? 189 over 2. 189 over 2, yeah. Okay. I can be funny sometimes, guys. I need to look at my calculator very well. Okay. 189 over 2. Okay, guys. Then minus for the parabola, when it's 7, definitely when it is 0, everything will go to 0 also. So this one, I have 7 raised power 3 divided by 3 minus, so let me just start plugging it. 7 raised power 3 divided by 3 minus 6 into 7 square over 2 plus 10 into 7. So that's what I have there. So that is 112 over 3. 112 over 3. 112. Let me check my calculator very well. 112 over 3. Yeah, cool. So guys, I think I'll just use my calculator to complete this one now. So the final answer now, and that is will give us the area. So 189 over 2 minus 112 over 3 equals, okay, so that is 343 over 6. Improper fraction. 343 343. So guys, you can go ahead and enjoy this, over what? Over 6. So let me get my answer in decimal form. SD 57.16. And they asked us to take it to 1 dp, so I will just go with 1 dp, guys. 57.2. 57.2. So guys, that is the end of, so unit square. Sorry about that, since it is area, we can just use unit square. So this is the end of the first question, guys. Let's go to the next question. Now let's take a look at the next question. This is question 2. Okay, so the diagram show part of the curve y equals to length s cutting the x-axis at the point 1, 0. So the normal to the curve at the point p e, 1 cuts the x-axis at the point q. So we have to show that the coordinate for q is this e plus 1 over e, 0. So guys, let's do that before I go to this next one. Let's take it step by step, guys. Now guys, since we know that this we have to find the coordinate of this. Okay, we want to find the coordinate of q here. And already we know that this line is perpendicular to the curve. So since the line is perpendicular to the curve, then we know that let the gradient of the line be of the curve, let the gradient of the curve be MA. And let me just work with it. Yes, let the gradient of the line be MA then, because I don't want to waste time, or let's just do the normal thing I used to do. So let the gradient of the line be MB then. So gradient of the line will be equals to minus 1 divided by the gradient of the curve, MA. So let me go ahead and find MA now. So let's keep this one here. Now I need to put a rectangular box. Yeah. So let's go ahead and find the gradient of the curve now. So to do that, we go ahead and differentiate the function as usual. Okay, so since I have y equals to ln x, then go ahead and do the differentiate the function. So we want to differentiate ln x. Okay, I don't know, do I need to be writing that because of my time? I will not be writing a lot of story again, guys. I'll just go ahead, don't mind. Okay, so don't forget that when you differentiate this one here, ln will give you 1 over x. Okay, so now at point, so we have it here now. So at this point now, you see that the x coordinate is e and the y coordinate is 1. So when x is e now, we can now get our gradient now. So our MA now, because we want a point value. Okay, so will be 1 over, so what is x? E, 1 over e. So MA is e. So from here now I can know what my MB is now. So my MB, the gradient of the second one here will now be my MB will now be what? Minus 1 divided by that. Minus 1 over 1 over e. So that will be minus e. Don't forget that negative inverse of 1 over e will be minus e. Okay, don't forget that. Okay, so guys, at this point now, let's just go ahead and find the equation of this line now. So the equation of the line will now be y minus y. I think I need to demarcate this thing now so that I'll manage my board very well. So let me just continue here. Okay, so now let's go ahead now. So y minus y1. So my y1 here is 1. Okay, don't forget my y1 is, so y minus 1 y1. So 1. Did I do anything wrong? The diagram show point the normal to the curve at point P. Cut the x-axis, so because it's normal to the curve. And so is this my gradient? Okay, 1 over x, and that is 1 over e, then negative inverse. So I'm cool, right? I think I'm cool, right? Yeah, so let's just continue. So y minus y1. So what's my y1? That's 1. So y minus 1 equals to m. Oh, sorry about that. The diagram shows the part of the curve y equals cutting the x-axis at this point. So the normal to the curve. So normal to the curve is negative, so it's different from tangent. So it's normal to the curve. Okay. So since it's normal to the curve, then I think I'm cool, because if m a is 1 over, oh, this is 1 over e. Yes, m is 1 over e. So mb is minus e. I'm correct. Okay, mb is minus e. So you use that. So it was sorry about that. I just need to be sure out, guys. I can't be. This is video. You have to be careful. Okay, so y minus y1. I just want to write the equation for you to see. Equals to equation of a given line perpendicular or parallel to the other line minus x1. Guys, we've been doing this a lot, guys. Don't let us waste much time. So this is the equation I'm using now. So y minus y equals to m. My m is minus e. Oh, sorry about that. Into x. Hope my stuff is not lagging already. Okay. Minus x1. My x1 is e. My y1 is 1. So minus e. So I'm going to open up now. Okay. Yeah, so I can go ahead and open up and find y, make y subject of formula. Okay, sorry, x. I make x subject of formula because I need this point q here is going to be, because this is boundary point x axis, so I go to get x comma 0 here. So when y equals to 0, I'm looking for the value of x, and that's the coordinate I want to find. When y equals to 0, what is the value of x? So when this one is 0, so I can go ahead and write this one. Now I don't even know what I put here. X minus c. Okay, so that's cool. So when y equals to 0, now let me just write this one because I'm looking for x. I can write, I don't want to waste much time. Let me just write this one here. So this 0 minus 1 give me minus 1. So I have x minus e, because I'm looking for x. X minus e equals to, when y equals to 0, yeah, I have 0 minus 1, that is minus 1. Then I divide both sides by minus e here to get x minus e. So minus. Okay, I should have, I can actually eliminate this minus e. Over minus e, no problem about that. Over minus e. So in this case, this one, we cancel this. So finally, my x will now be what? 1 over e plus e. 1 over e plus e, because when you move this one here, so I can rewrite it as e plus 1 over, say 1 over e is actually exponential, whatever. Okay, so that's correct. Okay, so this coordinate for x, so we've been able to prove that. So x is e plus 1 over e. I don't know whether I should write this one as 3 over 2, but you can see the answer here is correct. But let me just write it the way they want it. So e plus, because e plus 1 over e is same thing as 3 over 2e. Probably I may need to use that later, comma 0. So I've proved that. So this is when y equals to 0. When y equals to 0. So let's do the second question now. We have to show this. Okay, so if you differentiate this, you should get this answer. So let's go ahead and do that. So this is product rule, don't forget. X ln x. X ln x. So guys, I just want to manage my time and I will not really waste much time. So differentiate the first one, multiply by the second one, that is product rule. So when you differentiate x, you have 1, multiply by that, so you have ln x, plus differentiate the second one. When you differentiate ln x, that is 1 over x, times the first one. I don't know the way I was saying the first one, second one. So all I'm doing, you understand, I differentiate the algebraic times the ln function and vice versa. So differentiate this one times this, you have ln x, then differentiate ln x, you have 1 over x, then times x. Everything is pretty cool, guys, huh? Okay, I think you are good with this already. So you end up with what? Ln x plus 1. Ln x plus 1. Because inverse of x times x will give you 1. So, and that's what they asked us to show. So we've been able to prove that 1 plus ln x, that's it. Finally, let's find this. So let's go ahead and, guys, I will go with our calculus simplified by all method integration by parts. that shortcut. I just like this table method. It's just super cool for me. Okay, so the function I'm going to differentiate will be here, because this integration by parts, definitely you can see, you can write it as 1 ln x. Okay, and this will be the one I'm going to integrate. So don't forget the rule light. Okay, so ln function will be under differentiation. You give preference to ln function over every other function. Okay, ln and inverse, okay, maybe alternatively so, but this is ln x. So this is a constant here. It's like 1 ln x. Ln x same thing as 1 ln x. So 1 here. So differentiate ln x, you have 1 over x. Then integrate a constant. That's 1x. That is x. So don't forget to put your sign, plus, minus. For some reason, this thing will start. Don't lag, please. Okay. So hope everything is okay. So I'm going to differentiate this one here. So what's my answer now? So the answer here now will be so don't forget the way we take it here. Where is the arrow? You take this one, then I will now integrate that. Guys, if you need to go and watch my video on integration by parts, calculus simplify for all, guys, just go ahead and learn how to do this. Okay, so here now I have x ln x, this one times 6, s ln x. Okay, then this is minus, so minus, then integrate. Because I'm taking this one, I'm not taking this one down, so it's sideways. Minus integration of 1 over x dot x. So meaning that I'm going to integrate 1. So what's the final answer now? So that would be x ln x. Sorry about that, guys. This x ln x. My x is like karate. So x ln x, this one here, then minus. So this one will give me 1. So when you integrate 1, that will give you x. And since it is indefinite integral, you can just put plus c. So that's the solution to that. So that is x ln x minus x plus c. So hence find the area of the shaded portion region. So I'll just use the part 1 method for finding area. So because I have the coordinates now, I have the coordinates for the shaded portion. So the only thing about the shaded portion is that I need to be careful. So is it going to be p? What is this coordinates? This one 0. So I need to assign a name here. So that's what I'm going to do now. So just go ahead and, because, or better still, since you have this, if I don't want to use coordinates, coordinate will be the best thing for me. But let me just show you the second method, which I'm not going to do because it may take my time somehow, and it's need not to take my time anyway. But just method 2. Now this one, you don't even know whether it's the curve that is above the okay, because whether the curve is, if the curve is above the line, then you do the integration of the curve, then minus the line and with the limits. But I'm not going to do that because I have all my coordinates now. So go ahead and find the shaded portion now. And but from the question I have here now, so I know that I have PQ. So PQ or something like that, because I'm going to repeat the last one. This coordinate I have already. So this x now, I'm going to change it to, so that I'll be able to work with that coordinate. So that is 1.5, that is 3 over 2e. 3 over 2e, comma 0. So that I'll be able to use my coordinate method. Then I will now going to repeat the last one. Definitely I'm going to start with P. So this is E, the X, then the Y. 1. Then because this is a line, I can't go from this to curve. This is a line, so I have to come to PQ. So this is 3 over 2 now. 3 over 2 E, then 0 here. Then I can now go to this last one, 1 0. Guys, how to find area of any given polygon. If you have if all the coordinates are given, this is how to do that. Huh? So go ahead and watch the part 1 of the video, guys. Then you repeat the first one, E1, and this will give me my area, guys. So do your plus, minus, plus, minus. I think this is pretty cool, guys. I think I will not be careful using blue and blue and red every time. But let me do that, guys. So this multiply by this multiply by this multiply by this, then minus the other one. But let me do the plus part first so that I don't get everything mixed up. So this one goes to 0, this one goes to 0. Interesting, this is 1. So I have 1 minus, because this goes to 0, this goes to 0, 1 minus. Then I can do the blue part now. So this multiply this goes to 0 and this goes to 0. So minus 3 over 2e. Okay, guys, don't forget that we are going to do minus. Okay, so I think I'm cool, right? Am I cool? I should be cool. 1 minus, so 1 minus, then open the brackets. So don't forget that you do 1 minus, this one minus, then the blue part. I use red throughout, I'm sorry about that. This minus the blue part. Can I change it to blue so that I don't get you guys confused? Let me just change the color. So I say, which one is the blue part? Look, you confused me already. Sorry, I don't want to confuse you guys. Okay, so let me just change it to blue one. So don't forget I did this red one already. Okay, I did this red one. So the blue now. So this with this with this with this now. So I think everything is pretty cool. So I can complete it now. So minus, so the blue part now. So this is minus 3 over 2. Sorry about the handwriting. I can't just change that. No time. So this one goes 3 over, this goes to 0, this goes to 0. So what do you have now? So finally the answer is here. Can I just write it here? Let me just write it here. Let me just take blue. Let me just carve it here so that I'll just carve it here. So you end up with what? 1 plus, that's the answer now. Minus times minus is plus. So 1 plus 3 over 2. Am I correct, guys? 1 plus 3 over 2. I should be correct, right? Or 1.5. I don't know why I put this one as 3 over 2 because this is what I have here. E plus 1 over. I don't know whether I should just do that. 1 over 2e. Yeah, I think that's cool. That should be 1 over 2e if I'm not my calculator to do that now. So 1 plus 3 over 2. If you want a point value, guys, exponential, where is e? Alpha e. So the final answer should be 5.0. I'll check if there's any problem with that. So guys, this is the end of this section, guys. So let's go to the next section, guys. Let's go. Okay, guys, let's take a look at the next question, and it reads, given that y equals 1 over 4x minus 5 all raised by 8, differentiate y with respect to x. Okay, guys, let me just go ahead and demarcate my board so that we have enough space to complete the task. Okay, so now let's just go ahead with this now. Guys, don't forget I will not really waste much time with this question. You understand the shortcut already. So we fix the algebraic function and differentiate with respect to the index, the power. So now when you differentiate this one, 8 will come back here. So you have 8. Then open the bracket, and this is fixed 1 over 4. 1 over 4 x minus 5. And since we are differentiating with respect to power, then you take away 1 from that. So that's raised power 7. Then times differentiation of the algebraic function, and that is the function that is inside. And if you differentiate 1 over 4x, that will give you 1 over 4. Okay. And if you differentiate the constant, that will be 0. So you end up with what? The final solution to the first question will now be 2. Okay. Then open bracket, because 4 in this, that will be 2. 2 into 1 over 4x minus 5. Guys, hope that is clear. So that's chain rule. Don't forget, you just do the y over the x equals to the y over the u times u the the y over the x equals to the y over the u times the u over the x. But just go ahead with your shortcut, fix this, differentiate based on power times differentiate the algebraic form. So that's all. Okay, so we are cool with that. Okay, so that's the solution to the first one. Hope that is pretty cool. Next, hence, okay, uh yeah. So hence, find the approximate change in y as x increases from 12 to 12 plus p. So how do we do that, guys? So let's do this now. Approximate change. And guys, don't forget that if you want to complete any question on approximation, the first thing is to go ahead and differentiate the function. And thank God that's what we did in the first question. So I'll just continue from here now. So you go ahead and differentiate the function first. So the y, so the y over the x. That is when you differentiate this function here now. Okay, this raised power 7. Sorry about that. So when you differentiate this function, this is what we end with. Okay, so you differentiate this function, that's what we have here. So bring 8 back, then take away 1, then times 1 over 4, the way we have it here. This called this what that what we end there. So now, so the next thing now is that we now, when x is, because it increases from sorry, y changes as x increases from 12, x increases from 12 to 12 plus p. So the small increment there, the increment delta x is p. Okay, when x is 12, when x equals to 12. So go ahead now and get the value now. So now when x equals to 12, that is when x equals to 12, the given value, when x equals to 12, then you should know that the differentiation, the y over the x, okay, will be, sorry about that, and the y over the x will be approximately to partial derivative of y to x. Do you know why I write my approximation like that? Huh? Sorry about that. So how do you write something like a tider, like in computer? Okay, so partial derivative of y to x, provided this tends to as x, that is as x tends to 12, as x tends to 12. So this hold as x tends to 12. So let's go ahead now. So put anywhere you see x in the original function 12 now. So I have 2, open a bracket now, 1 into 1 over 4 into 12, 1 over 4 into 12, that will be 3. 1 over 4 into 12, that will be 3. 3 minus 5, sorry about that. 3 minus 5. I need to write my 5 very well. 3 minus 5. Okay, so all raised power 7. That is the y over the x now, as this. I'm trying to solve, get this now. So, and that's all. So what do we have in there? So that is 3 minus 5, that is 2. I think I'm going to leave it in this form. I'll just leave it like that, guys. So 2 into, this is minus 2, raised to power of 7. I'll leave it in this form, guys. I don't want to open up for now. So that this is what we have now. So this is the y dx as x tends to 12, as x increases from 12. So I don't need to write that again. So I can go ahead and use this can you call this is it a principle or lemma or theorem, guys? I can't talk about that. So I can go ahead and work with this one now. So you can now go ahead and write your partial delta y over delta x, because you are looking for the approximate change in y. So approximate change in y over approximate change in x. So approximate change in x, or let me just write the, let me write it first. Over approximate change in x, okay, is approximately to that value we have there. That is 2 into minus 2 raised power 7. So already we have this now. We have this because we know that delta x is p. So therefore our delta y, okay, will now give us what, 2, because this will be over p. So when you cross multiply, minus 2 raised to the power of 7 p. So guys, that's the solution to the question. So hope that is clear. So that's it. If you want to open up, go ahead and open up, but let me go ahead and do that. So 2 raised to the power of 7 is 128. So finally I can write my answer now. So my delta y, so 128 times 2 now, times 2, that is minus 256, minus 256p, minus 256. Sorry guys, hope that is clear. I will solve one more question on approximation, so for you to have a better understanding. So that's all. Let's go to the next question, guys. Let's go to the next question. Okay, guys, to help you enhance your knowledge more on approximation questions, so I decided to solve this two last question accordingly. So what I'm going to do is that I'll be solving the questions simultaneously so that you have a comprehensive knowledge of this type of question, because we do have this type of question in most of the exams. Okay, so and it's very easy, so it should be a walkover for you guys. So don't forget that if you want to complete any question involving, we look at the first one, says that given this function and hence find the approximate change in y as x increase from this to this. This also giving this function, hence find the approximate increase, so it's the same. Okay, the only thing that you need to know how to differentiate different type of function. So let me start with this very first one. So here I will go ahead and find the y, the x without wasting time. So let me just write the answer here now. So this is function of function, differentiate with respect to the power, so that is 5. Then you, because you fix your algebraic part, so minus 4x, then take away 1 from the power. Guys, you should know how to differentiate already. So this that's raised power 4. So that will be the solution to this. Go ahead and do the same thing here to differentiate this one also. The first thing now, you have to remove this square root and rewrite it in power form. So I can rewrite that question as 4x. So y equals to 4x plus 1, then raised to the power of 3 over 2. So 3 over 2. So that's the same thing as that's square root. So that's it. So this is what we have here now. So I will differentiate based on power now. So because this one is same thing as over 2. When you have square root of x means x raised power 1 over 2. So 1 over 2 times 3 will give you 3 over 2. Is that clear now? So now what I'm differentiating now, differentiate based on power now. That will be 3 over 2. 3 over 2. Then because you fix your algebraic part already, so open that now. 4x plus 1. Okay, is that clear? 4x plus 1. I'm not through with the other one. I'm just doing it like that. Then times, take away from the power 1. So that will be raised power half. So because 3 over 2 plus 1 will give you half. Then times differentiation of the algebraic part, because it's function of function. So this is dot 4 here. So I should have the same thing here also. Differentiation of the algebraic part here. 12 will go to 0, so this give it times minus 4. So the function you are dy dx here now, dy over the x, differentiate with y with respect to x here, we give you open up this one, we give you minus 20, then 12 minus 4x, all raised to the power of 4, 4x all raised to the power of 4, because 5 times 4 is 20, guys, don't forget. So that's what we have there. If you want to go ahead and do this one, I don't know whether I should complete this one because of my time, but let me try and do that. Okay, dy over the x, guys, I'm sorry about my handwriting, guys. So this will be 4 times 3 over 2. That will give you 6, right? Because 2 here, 2, so that will be 6. So 6 into 4x Guys, I think I'm cool with this already. What you just do is you're going to complete this accordingly. You I'm going to complete the first part, but I just deem it fit to show you this, and you go ahead and finish up this. So this is what we have, and then but I may need not to finish this, so I will use calculator to complete it. So let me complete this very first one now. So now when, because this says that x, find the approximate change in y as x increase from 0.5. So when x equals to 0.5, so when x equals to 0.5, just like the very last question now, then the approximation of differentiation of y with respect to x at that point, okay, will be approximately equals to change in y. I use delta for that, and divided by change in x. I see that the change in x here is p. P is a small change, but change in x, such that my change in y now, small increment in y, you can also use increment, will be equals to, and the value of this, so when x equals to 0.5 in this equation now, so let me just go ahead and use calculator to complete this one now. So 0.5, so 0.5 times 4 will give me 2. So 12 minus 2 will give me 10. Okay, so 10 raised power 4. Wow. So that this will give me minus 20. Then 10 raised power 4 will be is that not 10,000? Yeah, 10,000. So you just add how many 4 zeros behind that. Add 4 zeros behind it. 1, 2, 3, 4. And don't forget here, this is approximate as let me just write as x equals to 0.5 here, or 10 to 0.5 here. I don't need to write it because of my stuff is lagging, but you understand what I'm trying to do. As x equals to this now, so then p is delta x now is p. That is no change in x. And don't forget that I cross multiply. So this one multiplied by this. So delta y by delta x is sorry, the y by the x is this one here. When x equals 0.5, then times small change in x, and small change in x is p. So this is your answer here. So that is minus 20,000. Whoo, whoo, whoo. It's because I put bracket here. So this is minus 200,000. Sorry, this is how to put this thing. I'm not going to rewrite it. Oh, guys, I'm sorry about that. So minus 200,000 p anyway. I'm too playful, guys. So that's the answer to that. So the same, similarly here also, this one x increases from 6. So when x equals to 6 in this now, so we have let me just use now 6 times 4 is 24. 24 plus 1, let me confirm that 6 times 4, I'm sure 24 plus 1, that's 25. So 25 raised power half, that is square root of 25, that is 5. So 5 times 6, 6 times 5 is 30. So that is 30 now. So go ahead and do the same thing here now. So 30, this here we as undo, okay. So as x tends to 6 here, as x tends to 6 here, it's very difficult writing with this, I don't know. So I have 30, right? So the y by the x will be equal to 30. So you do change, small change your y, and I increment in y over increment in x. So I increment in x here is p over p equals to, and that one is 30. So what is the answer now? So small change in y will just be 30p when you cross multiply. Guys, this is the end of the tutorial, guys. At this point I want to call it a day. So guys, let me quickly show you something. Guys, don't go away. Let me show you something, guys. Just let me show you something. Okay, guys, here is my YouTube channel. Okay, so there are quite good numbers of video for you to enjoy here. Immediately after this session, I'm going to upload the video on differentiation and integration on my YouTube channels. Okay, so good numbers of videos, mathematics, additional mathematics, and robotic and coding ICT that will actually help you. Okay, so guys, you can see something like integration by parts, calculus simplified for all. This is some graph of trig function, simulating binomial distribution. You can also create your game using Scratch programming. You can develop AI using Python, and this is transformation, and quite good numbers of this video on robotic and coding. So guys, just go ahead, and if you find any of my video quite useful and helpful, just go ahead and click like. You can also subscribe to my channel. Also, I'm going to upload the same. I'm going to upload the worksheet and some board work also on my test shop, and also the video also be available here. Okay, so and also you have quite good numbers of board work on ICT mathematics, robotic and coding, additional mathematics here. And okay, most of the ICT and mathematics videos, board work, and worksheets here are actually exam style question, GCSE, IGCSE, IB diploma, and so on, A level. Okay, so guys, just go ahead and avail yourself. This is transfer application, quite good number sequence and rotation. So guys, go ahead and do well and take good care of yourself. If you find any of my also resources, e-learning resources quite useful, just go ahead and help to review the resource. Okay, like graph of trig function. Okay, so guys, do well and take good care of yourself, and do have a great day ahead. I love you guys. Bye bye guys. So let's end with this note, guys. Let's end with this note, guys.
Wake the streets up.